Hello viewers, this is Manas welcoming you to the series You the Oracle Expert, your one-stop shop to learn and practice Oracle database administration and Unix with hands-on experiments using Oracle VirtualBox virtual machines. Build your knowledge base, confidence, and make your way to be an expert Oracle DBA. In today's tutorial, we are going to learn about how to create a database environment health report using data from OEM 13C repository, BI Publisher report that comes free with OEM, and Microsoft Power BI, which is also free to be used in your desktop. Along with the DB target name and the host name, this report is going to give us a lot of information like CPU max, CPU average, swap max, swap average, IOPS max, IOPS average, Tablespace max, and data file system max utilization, and fast recovery area or archive area uses percentage, and if there is a standby, what is the apply lag of that standby database, and the top DB wait event along with the wait class. This is in fact enough for a DBA to find out what is the health status of the database and the server. You can also add backups related information here if you are using OEM to run RMAN backups, but that is not what everybody does, so I have not included this here. This method will work in OEM 13.4 onwards. I have divided into 3 parts as given below. In the first part, we'll write the SQL query to extract the data from OEM 13C repository database. In the second part, we'll create the report in BI Publisher report in OEM. And in the third part, we'll create the same report in Microsoft Power BI. So let's start. I have already developed the SQL query that will be used to extract the data from the OEM repository. You can use any DBA user or the sysman user itself to connect to the OEM repository database and run this query. As this is a very complex and large SQL statement, I have divided this query into smaller parts by a method called subquery factoring using the with clause. Each of the subquery is accomplishing a specific task, and I am joining all the subqueries in the main query to give us the final output. Although the query looks big and complex, it is not expensive and runs within a minute or so. So that way you won't have to worry about introducing any new performance issues in the database. This SQL query is getting the latest metric data collected for the database and host targets by the OEM agents. So every time we run it, it will give us the latest performance status of the targets. So we can schedule the report to come every hour or as per your desired frequency. I am also using analytical and hierarchical functions in these subqueries to give us the required information in the required format. If you want, you can go deeper into each of the subqueries to find out how it is working. And I am also making this entire query or any of the queries that I am using in this video available in a text document in my Google Drive, and you'll be able to download it from my Google Drive. The link for that file I have specified in the description of this video below. Now let me explain this SQL step by step in terms of what OEM management views and tables are being used, what fields are selected, and how I am formatting the data. And the first view I am using from OEM repository is the mgmt $target properties, which is giving us the list of targets and the host name. I am selecting specific targets from this view on which I want to create the report. If you remove this filter condition from the where clause, it is going to select all the database targets from your OEM repository database. You just have to make sure that whatever filter you are using here or whatever target name you are using here in this list, that target name is matching exactly with the target name that is displayed in your OEM repository, because this is going to be case sensitive. So for example, I am selecting here 3 targets, and this is giving me information about the OEM target name and on which host that particular database target is hosted. Now in the second subquery, that is giving us the tablespace uses percentage of all the tablespaces for the database targets that I am selecting in the first subquery. So here I am using a view called GC metric values, and that is being joined with the first subquery to filter out only the ones that we are interested. And if we see, the output is something like the entity name, that is nothing but the target name, the collection time, metric column level, and metric key value, that is the name of the table space and what is the usage percentage on that particular table space. And from this list of records, we are going to select only the latest one. Now the second subquery, that is the DFS uses PC, that is giving us information about the data file system uses percentage of all the file systems in that host where our target database is hosted. And here also I am using a view called GC metric values, and I am joining that particular view with our first subquery that is giving us the list of targets. So this subquery is giving us this kind of information, that is the host name, collection type, metric column level, entity type, metric key value, that is nothing but the file system name, and the usage percentage. And from here also we are going to select only the latest record. Now the next subquery is DFS avail MB, that is giving us the available space in megabytes in the data file system. And here I'm using the same management view, that is GC metric value, which is joined with the target list, and that is giving us the required information, which looks like host, collection time, metric column level, entity type, metric key value, that is the file system name, and the value, that is the actual available space in MB. Now the next one, wait EV sec, that is giving us the wait event in seconds that is happening in the target databases. And the same management view is being used, GC metric values, and it is giving us the total foreground wait time in seconds. So the data it is returning is something like entity name, that is the name of the target, collection time, metric column level, entity type, metric key value, and the value. So from here again we are going to select the latest record for that particular target. The next subquery is for CPU percentage, and here I am using the same management view, GC metric values, and it is joined with the target list to give us the CPU utilization percentage for that particular host. So the data it will return is something like the name of the host, CPU utilization percentage, CPU minimum percentage, CPU max percentage, and CPU average percentage. And out of these columns we are mainly interested in the max and the average, which we will be using in our report. The next one is about the swap utilization percentage, and it's using the same management view, the GC metric values, and target list is being joined with that to give us the output like the host name, metric column level, swap mean percentage, swap max percentage, and swap average percentage. The next one is for IOPS percentage, and also it is using the GC metric value, management view, which is again joined with the target list to give us the total disk I/O made across all disks per second. And the output of this subquery looks something like host, metric column level, IOPS minimum, IOPS maximum, and IOPS average. The next one is DBAs thresholds, and this subquery actually gives us the thresholds set for all the table spaces for the targets that are being used in our report. Because usually we have different thresholds set for the table spaces. For example, if the table space is very big in size, say a terabyte size table space, then we usually keep the thresholds a little higher than the smaller table spaces, which are like a few hundred GBs in size. We usually keep a lower threshold. So this particular view will give us what are the thresholds set for different table spaces, and the output will look like, say, for which particular target, what is the default warning thresholds and critical thresholds, and if there is any specific threshold set for a particular table space. The next one is Tablespace Max PC, that is the maximum percentage of uses on a particular table space. And it is also using the same management view, that is the GC metric values, and we are selecting the metric column level as tablespace space used percentage, and there are multiple levels of the subqueries, and the output of this particular subquery looks like this. For example, what is the maximum tablespace utilization for this particular database, that is the 27.7%, and for this database, that is ORCL1, this is 82.2. For ORCL2, there is nothing, means this database doesn't have a tablespace utilization, which holds good for standby databases. And in our case, this is a standby database. For that, there is no tablespace max percentage utilization. And the next subquery is for tablespace uses level. It means, for example, say a tablespace utilization is above the warning or above the critical, or it's below warning. Based on the status, it will give us a level like 0, 1, or 2. When it is normal or below warning, it will be 0. When it is 1, it will be considered as it has crossed warning, and when it is 2, it will be considered as it has crossed critical. So this is a little bigger in size, and the output it will give will look like this. Say for this particular database, usage level is 0, means it's still below warning, and this particular database, it's still 0, means it's still below warning. And this particular subquery, that is DFS Max PC, will give us information about what is the maximum utilization of the data file systems. Say you have 10 data files lying on 3 different file systems in your host, and which is the maximum utilized file system within those 3 file systems. That will be given by this particular subquery. So the output of this query will look like, say for this particular database, the maximum utilization of the data file system is 76%. For this particular database, this is 53.4. And for this one, ORCL1, it's 42.8%. Now the next subquery, that is the AFS uses PC, will give us the maximum utilization of archive file system or fast recovery area file system for that particular database target. And this is again a long subquery, and it is being unioned with multiple subqueries inside. And the output of this subquery, say for this particular target database, the maximum utilization of the fast recovery area or the archive area is 66.6%, and for the next two, it is 66.7 and 66.7% respectively. And the next subquery, that is the DB weight class. This will give us information about the database weights and under which weight class that particular weight event is falling. And the output of this subquery, say for this particular target database, the top weight event is resource manager related and it falls under system IO class. For the next two, again it is resource manager related and standby redo log IO related. The next subquery, that is the STBI lag, is for calculating the lag of a standby database from its primary database. So I'm using a view called metric current under sysman schema, and it is being joined with the target list. And the output is something like this. Say we have only one standby database from the list of targets that we specified in the beginning of this query, and that particular standby has an apply lag in second 0 and a transport lag second is also 0, means there is no lag of this standby. It's absolutely in sync with the primary database. And finally, I am joining all these subqueries, that is the target list, CPU PC, swap PC, IOPS PC, Tablespace Max PC, Tablespace usage level, DFS Max PC, AFS usage PC, DB weight class and standby lag, all these subqueries together based on a join field called the host or the OEM target name. And also I am using a outer join so that if any of the subquery is not returning any records, we'll still be able to see the information about the other metric being collected by the other subqueries. So when all these subqueries are joined together and we run this final version of the query, it will give us the records in a minute or so, and the output of the main query will look something like this. It will give us the OEM target name, the host name, CPU max, CPU average, swap max, swap average, IOPS max, IOPS average, tablespace max, usage level, data file system max, archive file system max, apply lag in second, transport lag in seconds, and the top DB weight along with the weight class. So our query construction is complete. Now before I go ahead and create the report, let me give you a quick background of the OEM BI Publisher report. BI Publisher report that comes free with OEM 13C is a easy to learn and simple tool to create and distribute database related reports. You don't need a separate license to use this tool as long as you are using it with OEM and the repository database. BI Publisher report is easy to use and configure, and it is replacing the Information Publisher report that used to come with the older versions of OEM. I have a separate video on how to configure and access this tool, and the link to that video is given in the description of this video below. So without spending more time in introduction, let's start creating the report. Go to the OEM. I used the sysman user to log in, and go to Enterprise, Reports, BI Publisher Reports. In the next page, at the top left corner, you'll be able to see the link to the BI Publisher report tool. Click on this BI Publisher report and it will open a new window. So I'm using the sysman user to log in and create report in this tool. You can use any administrative user to log in and use that user to create your reports. Next, we are going to create a connection to the database from where we will extract the data to be displayed in the report using the SQL statement that we developed. To create the connection, go to Administration, then go to JDBC connection. In my case, I have already created this data source with the name CatDB. Just for demonstration purpose, I will show you again how I created this. And here, you need to click on this Add Data Source. And here you have to specify a name of the data source, and the driver type will be same as database version, and it is going to be a JDBC driver which will be used to make the connection. And the connection string here, you have to specify the name of the host, the port, and the SID. So in my case, it will be my host name, the port is 1521, and the SID is also catdb. I'll put system user to make the connection to the database, and I will test the connection, and you see that the connection established successfully. Next, all you need to do is to apply these changes so that this data source is created. I will cancel this because the same data source is already created. So this is the data source that I just created, catdb. Now once the data source is created, the next thing to do is to create a data model. To create a data model, go to this new menu, then click on data model. In this window, click on this plus icon, then select the SQL Query option, and in the name box we'll type in DB environment health. This is the name of the dataset, and the data source will be selected from this list because we have only 2 data sources. I'll select the one that we just created with the name catdb, and type of the SQL statement will be standard SQL. And in this box we have to specify the SQL query that is going to extract the data, and we will simply copy it from the Toad window where we develop the SQL statement. But BI Publisher Report accepts the SQL queries that starts with a select keyword. In our case, our select statement doesn't start with a select keyword because we are using subquery factoring to simplify development of the SQL, and it starts with a with clause. So what we have to do, we have to use this query as a subquery that will supply the data to a parent query. So we'll simply put a select star from, and within bracket we will put the query that we developed earlier, and we'll close the bracket here. So we are simply putting the query that we developed earlier inside the brackets and using it as a subquery to the main query, which starts with a select keyword, and we'll run it just to test it for one last time, and we got the output. Now we'll copy this query and take it to our BIP Publisher Report window, and now we'll paste the query that we copied from the Toad window in the SQL Query box and click on this OK button. It will take a few moments to process the query, and the next step is to click on this data menu here and click on this view button to view a few sample records returned by the query. And this data is displayed in a tree view. If you want, you can display it in a table view by simply clicking on this table view link, and the data is being displayed in a tabular form. There are 2 more tabs that is giving us the structure and the code for this data model, and this structure is nothing but the fields that are selected and the XML tag name and also the display name of the fields. If you want, you can change it here. And this code tab is to display the XML code for the data model, and whatever data is displayed here, we need to save it as a sample data so that this can be used to create and format our report. So click on this Save as Sample Data button, click OK, and save the data model here. So you can save your data models and reports on specific folders there, or you can create your own. I am using the default folder named My Folder. We will save the data model with a name, say DM, that stands for data model for DB environment health, and we click on the save button, Now that our data model with the name DMDB Environment Health is ready, we are going to create a report using this data model. So click on this Create Report button, and in the Create Report options, the Use Data Model option is already selected, and also it is selecting the data model that we just created with the name DMDB Environment Health with an extension XDM. And how do you want to create your report? In this option, we'll select the Use Report Editor option here. We'll not select the Guide Me option, and click on the Finish button. Here we'll supply a name for the report, say DB ENV Health Report. Click on Save. Here in the Create Layout option, we are going to use the most basic one because we don't need any tables or charts in our report. It's going to be a simple tabular report. So let's select the blank portrait option here. And in this canvas, we'll first place one report header. So click on this text item, just drag and drop. Then put a report header as DB Environment Health Report. Select the text, make it bold, and the size as 16 point, and center align. And our report is going to be a wide one because there will be a lot of information displayed, so we need to make it a little bigger by selecting the landscape option, and also the size of the paper will be legal so that we can maximize the space to display our information. Now, to display the data in the report that belongs to the CPU utilization, swap utilization, etc., we'll create a data table here by doing a drag and drop of this data table object here and place it below the title. And in this box, we are going to place the fields that we want to display in our report. So the first field will be the OEM target name, then the host name, CPU max PC, CPU average PC, swap max PC, swap average PC, and we can see that we don't have enough space there, so we'll have to adjust the width of the fields by a little. And also we want to change the column headers. We'll put simply a percentage symbol there instead of PC. You can simply double click on the text to be edited and make the changes, then press enter. Now we have enough space there. Let's drag and drop the other fields: IOPS max PC, IOPS average PC, Tablespace max PC. And usage level, we are not going to use this field in this report directly. Instead, we are going to use it to change the color of this Tablespace max PC, and that I'll explain later on. Then DataFS max PC. Again, we have to do some editing here and reduce the width. You can see there is a total line which we don't want in our report. So we'll click on this box, and in these styles available, we'll select the one that doesn't have the total line. So the first option we selected, and the total line is gone. And then the ARC FRA file system max percentage utilization, that is the archive file system or fast recovery area uses percentage. Then the apply lag in seconds. And we are not going to use the transport lag in seconds because the apply lag in seconds is more important for us than the top DB wait event. And we'll adjust the column width accordingly and we'll save it. And we have to provide a name for the layout here. Let's give it a name as layout 1. And now we are going to format these cells with different colors based on certain threshold values. And these threshold values that I am going to set here are not absolute. For your environment, you'll be able to customize it as per your requirement. For example, CPU Max, Swap Max, and IOPS Max, these columns are actually giving us if there is any spike for that particular area. The average columns are giving us an idea about how the server status is throughout the day. So in fact, these average columns are more important for us. As the average columns are more important for us, I'm going to set a slightly lower values in the thresholds for these average columns than the max columns. So let's start. I'm starting with the CPU Max. Click on the column itself, and when it is selected, click on the highlight button here. And the CPU Max will set a threshold as if the value is greater than or equal to 90, then it will be considered as a critical situation, and the color of the font will be represented with white color, and the background color of the cell will be red. Click OK, and then we have to add some more rules there by selecting this Manage Format button. And when this row is selected, click on this plus button. And when the CPU Max percentage is greater than or equal to, say 80, it is considered as a warning situation, and the background color will be yellow. The font color will be black by default. Click OK. One more rule. When the CPU Max percentage is below 80%, it will be considered as normal, and it will be represented as green background for the cell. Click OK. Now for the average column, which is actually more important for us, we'll set slightly lower values in the thresholds. So we'll click the highlight button. CPU average percentage is greater than or equal to 50, then it will be considered as a critical situation, and the color of the font will be white, and the background color of the cell will be red. Click OK and OK again. Then click on the Manage Formats to add some more rules there. Click on this plus button. When the CPU average percentage is greater than or equal to 40, then it will be considered as warning, and it will be represented with a yellow background color in the cell. And when it is less than 40, it will be considered as normal situation, and the background color of the cell will be green. Click OK. So here are the rules. When the value is greater than or equal to 50, it will be critical. When it is greater than or equal to 40, it's warning. When it is less than 40, it's normal. You can change these values as per your requirement. Similarly, I'll set different threshold values here. Say for example, the Swap Max, the critical threshold will be 90 and the warning threshold will be 80, and the normal will be below 80. But for average, critical threshold will be 50, warning threshold will be 40, and the normal threshold will be below 40. For the max IOPS, the critical threshold will be 2000, the warning threshold will be 1500, and the normal threshold will be below 1500. For the IOPS average, critical threshold will be at 1500, warning threshold will be 1000 and normal threshold will be below 1000. For data file max percentage utilization, the critical threshold will be 90, warning threshold will be 80, and normal will be below 80. And for archive file system or FRA Max utilization, the critical will be 75%, warning will be 50%, and below 50 it will be considered as normal. For the apply lag seconds, 60 seconds will be considered as critical, 30 seconds will be considered as warning, and below 30 it will be normal. For the top DB wait events, there will not be any colors to represent the critical or warning situation. Now once we set all the threshold values for these columns, the CPU, swap, and IOPS, they will look like this. Next, we are going to format the color for the Tablespace Max utilization. The Tablespace Max utilization column, for this, the formatting rules will be a little different, because as if you remember that the threshold values of the Tablespace utilization differs depending on their sizes. For bigger tablespaces, we used to set higher threshold values than the tablespaces which are smaller in size. So that's the reason our SQL statement is giving us another column called usage level, which is taking 3 different values based on the usage level of the tablespace. For example, the usage level column will have a value 0 when the usage status is normal, and it will take a value 1 when the usage status is warning, and it will take a value as 2 if it is critical. So to determine what color will be taken by the cells, we will use the usage level field value, and we will not set any other thresholds. So let's start. Click on this column called Tablespace Max percentage. Click on the highlight. Now instead of the Tablespace Max percentage utilization, we will use the usage level column here, and if it is equal to 0, it will be considered as normal and will be represented with a green color in the cell. Click OK. Click on the manage formats. Add a new rule. When the usage level equal to 1, it will be considered as warning, and the background color of the cell will be yellow. Add one more rule. When the usage level is 2, it will be considered as critical, and the font color will be again white, and the background color will be red. Click OK, and now we can see that the last row that represents our standby database has no values there, because for standby databases we don't collect any statistics for the tablespace utilization. So that's the reason it is blank here. Now the data file system max utilization, again we will set some values. Now our formatting part is done. We'll save it and click on the Done button. Now the main part of designing the report is completed and it is saved. Now if we go and click the catalog menu, we'll be able to see that our report is there with the name DB Environment Health Report. You can access this report for editing or displaying or distributing. For any of this purpose, you can go to this catalog menu and go to the folder where your report was saved, and you can do the required activity there. And similarly, you can also modify the data model by going to the catalog menu first and then go to the folder where that data model was saved and do your required activities. Now to look into this report, there are two ways. You can either click on this open button and that will show you the report in the screen, and the data will be dynamically refreshed using the query that we set in our data model. Now if you see that it is showing that sometime during the day there was a spike in CPU utilization for this particular server, and we can see that there's a 100% utilization, and also for this server we can see there's a 99.3% utilization, and in the average column we don't see any critical or warning situation. Similarly, the other columns also giving us useful information about how our database environment is working. Now this report is being displayed by default in an HTML format. If you want, you can change the format to a PDF or a RTF or an Excel document by selecting different options which are visible under this View Report menu. Now this is one way of looking into the report, but the most useful way is to distribute this report through emails to the people who are interested to look into it, or the intended recipients in your organization. To do that, we have to schedule this report. You need to make sure that the SMTP server has been configured with the BIP reports, and I assume that if you're using OEM in your organization, the SMTP server has been already configured. If you have not configured the SMTP server and the port etc. for BIP report, please watch my other video where I have demonstrated how to configure it, and the link to that video is given in the description of this video below. So I'll not spend time in explaining how you need to configure the SMTP server, port, and other notification methods, etc. Now I'll go to the catalog menu again, and I will schedule this report so it runs by a job on a specific time and distribute to the intended recipients as email. To do that, click on this schedule button, and under the schedule, click on the output. You don't have to select the save data for republishing, because every time this report will run, the purpose is to get the latest information. And you can select this make output public, or you can keep it unselected. This is fine. Now name by default, it will be output. You can change this name to something like DBENV Health Report. Layout will be by default the layout 1, and if we created multiple layouts of the report earlier, we'll be able to select which layout will be actually used by this particular scheduling job. For us, there is only one layout available, so it is showing only one option there. And the format by default, it is HTML. You can select different formats there. Now if you select a PDF format, the report will be distributed as a PDF, and the name of that PDF will be this name that you have specified there, DB Environment Health Report.pdf, something like that. Now we are not using the PDF option. Instead, we want to display the report in the body of the email itself. So we are selecting the HTML format there. Now under the destinations, make sure that the email is selected, and this list will be populated based on what distribution methods you have configured. It may be an email, or it may be a fax, or it may be something else that you have configured in the distribution methods. Now add destination. If we click this button, it will give us the option to specify the email address. Say I'm selecting my email address there, and the subject line you can specify as same as DB Environment Health Report, And you don't have to specify any message there, because in the body of the email, our report will be in the HTML format and we don't want anything else to be displayed there. Now, next thing, click on this schedule button. You have the option to run this report once, or you can run it hourly, daily, weekly, monthly, annually, etc. in different frequencies. Say I'm running it once and I'm selecting the option run now, means it's going to run the report and distribute to the email distribution list as soon as we submit the job. So I have selected once as frequency and run now option there. The notification tab, I am not selecting anything. It is used to notify whether the report has been successfully completed, it failed or skipped, or whatever status it is for the job. And also I am not selecting anything for the diagnostics. It will give us some information if the job actually fails. Now, once everything is set as per the requirement, all you need to do is to click on the submit button, and it will ask for a name of the job that I'm going to give the same as the name of the report, say DB Environment Health Report Job, and I will submit it. And I get a confirmation that the job DB Environment Health Report Job successfully submitted. Click OK, and if everything is correct, I'll be able to receive one email in the email ID specified with the report in HTML format. Now, if your email server configuration is properly done in the BI Publisher reports, you should be able to receive a report like this that I'm displaying. This is a regular report that I am receiving for some of the critical databases, and I hope that a report like this will be useful for you also. Now, before I go ahead and create the report, let me give you a quick background of what is Microsoft Power BI. Microsoft Power BI is a very useful tool that provides business analytics service with interactive visualizations and intelligence capabilities for end users to create their own reports and dashboards. The desktop version of this tool is free to use, and I have given below the link to download it. You can use this easy to learn tool and create informative and interactive reports and dashboards. You need to have proper license to publish your work at organization level. I have a separate video series on how to download, configure, and use this tool to create reports, starting with simple ones to a variety of complex ones with different visuals. And the link to the video series is given in the description of this video below. So let's begin creating the report using Microsoft Power BI. Now, once you start the Power BI application, the console will look like this. And the first thing you need to do to create the report is to get the data. So click on this Get Data button and click on this More item. And under the Get Data options, click on this Database item. And from the right hand side list, click on the Oracle database. Then click Connect. In this box, you have to provide the connection properties like the server name, port, and the SID or the service name of the database. So I'll specify my server name, admin server manash.home : 1521 is the port number / catdb.manash.home is my service name. And next, select this import option. And the direct query option can also be selected, but if you select this option, every time you run the report, your report is going to connect to the database to pull the data. So I'm selecting the import option here. You can skip the command timeout in minutes option here. Then I'll specify a simple query just to make sure that the connection has been established. So I'll put a query like select sysdate, put an alias for the sysdate as SD from dual. So this is a simple SQL statement I'm using here just to test the connection to the database. Then click OK. In the next screen, it will ask for the credentials. So we'll select the database option, not the Windows option. And I will specify the system user to connect to the database and click connect. If everything is correct, in the next screen you will be able to see the data that has been pulled. So this is the sysdate and the alias SD, which is displayed in this data grid. And now you need to click on this load button. It will take a few moments and the data is loaded to the data model, but it is not yet displayed into the canvas. So we have three options here: the report that represents the canvas itself, and the data grid, and the data model. So we'll go back to the report option there to design the report. And in the right hand side we see that there's a query 1, which is nothing but the SQL query that we use to pull the data, and we have to replace that test query with the actual query that we want to pull the data from our OEM repository database. So click on these three dots at the right hand side for the query 1, and it will give us the option to edit query. And in the next screen, click on the advanced editor button. In this window, all we need to do is to replace this test query with our actual query that I'm going to copy from the Toad window. So let's go to the Toad window, and from here I'll simply copy our query to the Power BI window. I will replace this test query within the two double quotes with the actual query. I just pasted it using Ctrl V. Make sure that there is no extra lines and click on the Done button. Click on the Edit Permissions button again and click on Run button. It will take a few moments to pull the data and display in the grid. Now our data is displayed. Next, if you want, you can rename this query 1 to something else. I'm just leaving it like that. Close this window. It will ask for saving it. Click yes, and then it will load the new data again. Click the Run button again if it asks, and the data to the data model has been loaded, and we can see that the query 1 structure has been changed, and now we can see the actual fields in the list of fields there. Next, in this canvas we need to put a report header. So you can click on this text box, drag it to the end, and we'll put a name like DB Environment Health Report. Make it a little larger, bold, center align. And then to display the data in the report, first we have to place a visual in this canvas, and that visual list is here. We have a lot of choices there, like if you want to represent your data in a graphical format, you can select these pictures or graphs from this list. But in our case, we are going to display the data in a tabular format. So you can simply click on the table visual there, and it will be placed in the canvas automatically. And it is there. Increase the height a little. Now to display the fields, we can simply drag and drop the fields that we want to be there in the required order. To make some more room for the information that is displayed here, I'll simply collapse these two windows, which is not needed at this time, and increase this one by a few centimeters. And now I can see all the names in this list. First one is the OEM target name. So click on this checkbox and it will be automatically placed there. Next thing, the host. Then CPU max, CPU average, swap max, swap average, IOPS max, IOPS average, then data file max, archive or FRA file system max, then the tablespace max, then the apply lag in seconds, and finally the top DB wait event. We are not selecting the transport lag, and the usage level will be used to format this tablespace max percentage utilization column. I'll explain it later on. Now we see there is a line totaling all these numbers which we don't want. So to remove that, click on this table, expand this visualization window again, go to this format option, and in this list expand this total button and switch off the totals line, and it's gone. Since all our required fields have been selected, now we can collapse this window to make room for the other windows. Now we see that all these numbers are having decimal places which we don't need. So to remove the decimal, again select the table. Under the formatting options, expand this field formatting list here. Select the appropriate column. In fact, all the numerical values here. So we'll first select the CPU Max PC, and in the value of decimal places, we'll put it 0. And in the CPU Max PC, the decimal place is gone. Similarly, we'll do it for the other numerical fields also. Now all the decimal places are gone, and now we want to reduce the font size by a little so that the fields are visible in this page. When the table is selected, go to the formatting option again, go to the grid, and here we will reduce the text size to 8. Now all our fields are visible in one window. You can also do that by increasing the page size, but this one is easier and it's going to work for us. That's the reason I selected that option. Now we need to modify the column headers because we don't need this underscore PC at the end of all these names. Instead, we want to display a percentage symbol there. So to do that, you can simply click on the field header or the column header, and in this list of columns, so simply double click on that name and make your changes. Similarly, select the other fields also where you want to display a percentage symbol instead of the underscore PC. And the renaming of all these column headers have been completed. Now in this report, the CPU max percentage, CPU average percentage, swap max percentage, swap average, IOPS max, IOPS average, data file system max, these are all server level statistics. Whereas the archive file system or FRA percentage, tablespace max utilization percentage, apply lag in seconds, or top DB wait event, these are database level statistics. The max values tell us if there was a spike sometime during the day, and the average values tell us how the overall server health was throughout the day. So in fact, these average values are more important for us. Now we will format this report with different colors in the cells and fonts based on certain threshold values. For example, in the CPU max percentage column, if a value is greater than or equal to 90, then it will be considered as a critical situation, and the cell color will be represented with red and the font color will be in white. And if the value is greater than or equal to 80, then it will be considered as a warning situation and the cell color will be changed to yellow. And if the value is less than 80, then it will be considered as a normal situation and the cell color will be in green. But in the average column, we will set a slightly lower values in the thresholds, such as if the value is greater than 50, then it will be considered as a critical situation, and it will be represented with a red color in the cell and the font color will be in white. Similarly, if the value is greater than 40, then it will be considered as warning situation and the cell color will be in yellow, and if it is below 40, then it will be considered as a normal situation and the cell color will be in green. Similarly, for swap max and average columns, it will be 90, 80 and less than 80, and 50, 40 and less than 40 respectively for the critical, warning and normal utilizations. And for the IOPS max and average columns, it will be 2000, 1500 and less than 1500, and 1500, 1200 and less than 1200 respectively for the critical, warning and normal situations. For data file system max utilization, it will be 90, 80 and less than 80 respectively for critical, warning and normal situation. For archive file system or FRA percentage utilization, it will be 75, 50 and less than 50 respectively for critical, warning and normal situation. For the tablespace max, the status will be actually given by another column called usage level. If you see, we have an extra column called usage level, which is not used directly in this report, but this field will be used to determine what is the usage level of tablespace, and based on that we will decide the color. For example, this usage level column takes only 3 distinct values, 0, 1 or 2. If it is a 0, then it is considered as a normal utilization. If it is 1, then it will be considered as a warning situation, and if it is 2, then it will be considered as a critical utilization of the tablespace. So that's the reason this particular column or the field is not directly used in this report, and instead we are using it to determine what color will be given to the tablespace max utilization cells. Similarly, for the apply lag in seconds, the critical situation will be when the lag is greater than or equal to 60 seconds, and the warning situation will be when the lag is greater than or equal to 30 seconds. And if the lag is below 30 seconds, then it will be considered as a normal situation and the color of the cell will change accordingly. For the top DB weight event, there will be no change in colors. Please note that these thresholds that I am using as examples are not absolute, and you can change it as per the requirements of your environment. Now let me show you how I set these thresholds using a feature called conditional formatting in Power BI. I will show it just for the CPU related columns and the tablespace column. For the remaining, I will simply fast forward it. So let me first take the CPU max column. First, select the table and go to visualization options. Here, click on this formatting option, then go to conditional formatting here, expand the list and select the CPU max percentage column. And we are mainly interested in changing the background color of the cell and font color, so we will switch these two on and this one. Now click on the advanced controls for background color. In this window, we will change the format by option to rules and applies to values only. You can leave it like this, sum of the CPU max percentage, although it is not actually summing up, but by default it goes to sum, and let it be here as summarization. And if the value is greater than or equal to, say 0 and less than 80, then it will be considered as the normal situation, and this has to be number and number, although we know these are percentage values, but actually these are represented as numbers here, so we'll select the number option there. And then the background color will be green. Here we'll select the farthest green zone here, and then add a new rule. If the value is greater than or equal to 80 and less than 90, then it will be, of course we have to select number here, then it will be a warning situation, and we'll select the yellow color in the cell. Now add one more rule there. If the value is greater than or equal to 90 and less than equal to some maximum values, you can leave it blank. It will automatically take maximum. Then the color of the cell will be red. And press OK button. Now we can see that the color of the cells have changed, but we have not changed the font color yet. So click on these advanced controls under the font color section and we'll set the same rules there. Rules applies to values only. Let it be sum. Then if the value is greater than or equal to 0, number, and less than 80, number, then the font color will be black. Add a new rule. If the value is greater than or equal to 80 and less than 90, number, then also the font color will be black. And a new rule, if the value is greater than equal to 90, number, and less than equal to a maximum number, then the font color will be white. And now we can see that the values and the cells are more distinct now. Similarly, we'll set the thresholds using conditional formatting on this particular column, CPU average percentage. So again, in this list, select the CPU average percentage, switch on the background color and the font color, click on the advanced controls. Here we'll select the rules, values only, sum, and if the value is greater than or equal to 0, number, and less than, say, 40, number, then it will be considered as a normal situation with a green color. New rule, greater than equal to 40, number, less than 50, then it will be considered as a warning situation with yellow color. New rule, greater than equal to 50, number is less than or equal to a maximum number, then it will be with red color. Press OK. And also we have to make the changes in the font color. Click on the advanced controls, rules, values only, sum. If the value is greater than or equal to 0, number, and is less than 40, number, then the font color will be black. New rule, greater than or equal to 40, number, less than 50, number, then also the font color will be black. New rule, if the value is greater than or equal to 50, number, and is less than equal to a maximum number, then the font color will be white. And now you can see that the cells are not in critical values, so we have the expected colors there. Now I will set the conditional formatting for all the server related columns with the thresholds that I described before. So our conditional formatting is completed until this column, archive file system or FRA percentage utilization. Next we'll take the Tablespace max utilization, and for this we have to use this usage level column. So go to the formatting options and under conditional formatting select the Tablespace max percentage utilization. Switch on the background color and the font color. Click on the advanced controls under background color, rules, values only. Here, based on field, under this we have to select our usage level column. And this sum, whatever summarization it is doing, it is not going to make any difference for us, so let it be there. And if the value is greater than or equal to 0, number, and less than 1, number, then it is normal. New rule, if it is greater than 1 number, less than 2 number, then it is warning condition with yellow background color. New rule, if the value is greater than or equal to 2 number and less than the maximum number, then it will be red. Click OK. Then we have to change the font colors also. Click on the advanced controls under the font color options, rules, select the usage level field. If the value is greater than or equal to 0 number and less than 1, then the font color will be black. New rule, if the value is greater than or equal to 1 number and less than 2 number, then it will be black again. Please note that I am segregating this into 2 different rules, but if you want, you can also make it 1. Instead of 0 to 1 range, we can put 0 to 2 range there. And again, new rule, if the value is greater than or equal to 2 and less than the maximum number, then the font color will be white. I just refreshed the data by clicking on this refresh button, and we can see that that some of the values in this grid have changed and also their formatting colors. For example, if you see this ORCL1, this particular database, it has no tablespace related information. It's because this is one of the demonstration databases, and this database has been down for more than 24 hours and no tablespace related metric has been collected in the last 24 hours. That's why nothing is displayed here. This ORCL2 is the standby database for this ORCL1, and for standby databases, by default, OEM will not collect any tablespace related information. Similarly, for apply lag seconds, which is only relevant to the standby databases, it is shown as 0 because both these databases are down currently. Now, to make this report a little nicer and more appealing, we will make some cosmetic changes. For example, let's make the background of this canvas a little different than white. So when the canvas is clicked, go to this formatting option, go to the page background, and here instead of white, let's select dark blue and the transparency will be 0. And similarly, let's make some change to the text box which is displaying the report header, and for this, select the text and make the color white, and the background of the text box will be 100% transparent, so that whatever is the report background, that will be visible through the text box. Now click on this data table, and here we have to make the report headers a little bold. So go to the formatting options again, go to the column header, and in the font family, select a little different font, say SQL UI bold. Now the headers are more distinct than before. Now in the same grid, let's make the data also a little bold. Go to the values, and in the font family, select SQL UI bold. And we can see that the data is also now more distinct than before. Now we'll also remove the background of this data table. So we'll simply unselect this background option under the formatting options of this table. So switch off this background option, and now the white background is gone. And when all our formattings are done, our report will look like this. Next, we need to configure the options to distribute this report to the people who are interested to see this. And please do not forget to save your report using the save button, and it will save the report with an extension as PBIX. If you have the free desktop version of Power BI, then you can refresh this report periodically and manually, and then send a screenshot to the intended recipients as email attachment. That is the zero cost option, but will take some of your time. If you have the professional license for Power BI, you can schedule the refresh, publish the report using this publish button at an organization level workspace, and share the report as a web link. Once you publish your report, it will appear in the organization level workspace as shown here. Each of the report has its corresponding dataset also listed in this workspace. People who has access to this workspace will be able to directly see these reports by simply clicking on this hyperlink. But you also have the option to share it by the share button here, and send the share link to one or more email IDs. You can also copy the link address from here and send it to specific people in your organization. In the dataset, you have the option to refresh it on demand, or you can schedule the refresh by clicking on these three dots here. Then go to settings, and under settings you go to schedule refresh option, switch it on or off, and specify the time at which you want this report or the dataset to be refreshed. So viewers, I hope you enjoyed the video and found it useful. Please hit the like button if you liked it, and subscribe to my channel so you won't miss an episode in this series for the Oracle DBAs or similar educational videos that I am uploading every week.